All right, this is section 2.2, the graph of a function for precalculus. If you're given data points, you can plot the points on a graph as such. Determining whether a graph is a function or not is an important component of the next couple of years of math you'll take. So we're going to apply the vertical line test, and essentially what the vertical line test is a straight up and down line. If you lay it over your graph and it touches more than once, it is not a function. So let's see what that looks like here. So if I have a vertical line like this dashed line and I move it along my function, in this case, wherever I lay that vertical line, it only touches once. So this is a function. I do the same thing with this nice cubic function. I move this line back and forth. It only touches once at any moment, so it is also a function. Not functions, definitely this vertical line touches this horizontal parabola twice, so definitely not a function. And circles, you can include ellipse and hyperbola to this as well, touch more than once when you lay your vertical line on it, so it is also not a function. All right, so being able to look at a graph and get information is really important. So like when I have an x value of 0, what is the y value? 4. When I have a x value of 3 pi over 2, the y value is 0. When I have an x value of 3 pi, my y value is negative 4. So the domain of f, now I only have this function from 0 to 7 pi over 2, or actually to 4 pi. So my domain is 0 to 4 pi. I don't have the equation, so I just have this little snippet, so I have to go with my domain from 0 to 4 pi. The range is from negative 4, which is the smallest y value I have, to 4, which is the biggest y value that I have, and that's inclusive. The intercepts, we did that last time, are 0, 4, pi over 2, 0, 3 pi over 2, 0, 5 pi over 2, 0, 7 pi over 2, 0. How often does the line y equals 2 intersect the graph? It intersects at 1, 2, 3, 4 places. For what values x does f of x equal negative 4? So I want to find the line negative 4, which is right here. So it happens when x is equal to pi and when x is equal to 3 pi. And for what values of x is f of x greater than 0? Well, that's this section here from 0 to pi over 2. It's also from 3 pi over 2 to 5 pi over 2. It's also from 7 pi over 2 to 4 pi. And that is a union because all these sections are combined. All right, let's consider a function. X over x plus 1 is the point 1 comma 1/2 on the graph. So we plug in 1 for x and we see if we get out 1/2, and we find that we do. So that's a yes. If x is equal to 2, what is f of x? What point is on the graph of f? So we're going to plug in 2, and we get out 2/3, so the point 2 comma 2/3 is on the graph. Next, if f of x is equal to 2, what is x? So we are going to let our function equal to 2 And the way I would solve this is I would say this is 2 over 1 equals x over x plus 1. We are going to cross multiply. So we get 2 times x plus 1, and x equals x times 1. We distribute out the 2. We subtract 2x from both sides and divide by -1, and we get x equals -2. So the point on the graph would be -2, comma 2. All right, we're going to use our graphing calculator to find the average, to fuss with this average cost function. So we input this equation as y equals 0.56x squared minus 34.39x plus 12.57 plus 20,000 over x. We put that into our graphing calculator, and we find out when x is equal to 30, y is equal to 1,351.54. When x is equal to 40, y is equal to 1,232.97. When x is equal to 50, y is equal to 1,293.07. When you look at the graph, it sets our domain for us. It wants us to graph it between 0 and 80. And then it wants us to create a table with table start at 1 and our delta table there, our change in our table, to equal 1. So let me show you real quick on Desmos what that looks like. So here's our function. We started at 1 and we just keep going. And you input the function, and you can see here's all these little data points. It wants to know, the question it's asking is, there's what the graph looks like. Here's our delta table counting by ones. And then which value of x minimizes the average cost? So you go down and you look at all of your data. Right now it's it maxes out right here at about 7,781. So we want to keep scrolling, keep scrolling, keep scrolling until I reach a point. If you look at 40, I get 1,233. 41 is 1,231, and then it increases at 42. So we know 41 is the x value that minimizes the average cost, which is 1,231.74. All right, and that's the end of our lesson.